this video, we are going to talk about the gas laws. Before talking about the gas laws, we need to know that there are 4 variables to specify a sample of gas in calculations. Those variables are pressure, we show it with P, volume, V, number of moles, and temperature, T. So about temperature, we should know that the unit for temperature should be in Kelvin. And if we have the temperature in degrees of Celsius, we can simply add 273.15 to degrees of Celsius to have it in Kelvin. In order to determine different gas laws, we need to hold 2 of these variables constant and observe how the other 2 affect each other. We know that there is an equation PV equals nRT for ideal gases. This formula relates all of these variables to each other. In order to derive any of the simple gas laws, you need to rewrite this equation for condition 1 and condition 2 and divide them by each other. So, condition 1 we have P1, V1, N1, R, T1. So R doesn't have any subscript because it's a gas constant and it's always the same in all the conditions. Condition 2, we have P2, V2, N2, or T2. So you just need to simply divide these conditions by each other. N2 or T2. For example, if I want to know how volume can change versus pressure, what I need to do is to keep number of mole and temperature constant. That means N1 should be equal to N2 and T1 should be equal to T2. So let's look at the equation. P1, V1, N1, or T1, and we have P2, V2, N2, or T2. So if N1 and equals to N2 and T1 equals to T2, we can simply cancel out these variables, and R is also constant, so it can be cancelled out, and we will have P1 V1 over P2 V2 equal to 1. If I rearrange this equation, I will have P1 equal to P2 B2. That equation is one of the simple gas laws, and the name of that is Boyle's law. So, and Boyle's law tells us that pressure and volume are inversely related with each other. So as you can see in the picture, we have a container, 1 liter container, and the pressure of the gas inside is 1 atmosphere. If we apply more pressure on the container by putting a heavier weight on top of the container and basically increasing the pressure, the volume decreases. So it shows us pressure and volume are inversely related with each other, which is a Boyle's law. Now, what is R? R is the gas constant, and that is measured under the STP standard temperature and pressure condition. And after the calculation, the value for that is 0.082 liter atmosphere per mole per Kelvin. Now, what is STP condition? The condition of 1 atmosphere pressure equal to 1 atmosphere and temperature equal to 0 degrees C or 273.15 Kelvin are called STP condition. And under this condition, 1 mole of all gases can occupy the volume of 22.414 liter. Putting these conditions in the PV equals to nRT formula, ideal gas formula, we can calculate the value for R. The wooden cube in the right shows the volume of 22.4 liter, which is the volume of 1 mole of a gas at STP condition, and you can compare that volume to the known objects such as basketball and football. Now, application of the gas laws. A sample of helium occupies 535 milliliter at 1.3 atmosphere and 25 degrees Celsius. If the sample is transferred to the 1.05 liter flask at 25 degrees Celsius, what will be the gas pressure in the flask? So as you can see, we have two conditions here. Line 1 gives us the information about condition 1, and in line 2 we have information about condition 2. So we have P1 V1 equals N1 R T1, and to solve this problem we need to divide condition 1 information by condition 2 N2 R T2. So R is the gas constant and we can cancel that out. If you read the question, we have in both conditions the same temperature. So that means the temperature is constant. Also, we transferred the whole sample of helium to the condition 2. That means the number of mole is also constant. We transfer the same amount of sample and molecules to the condition 2. So we can cancel out temperatures and moles from this equation. So we have P1 V1 over P2 V2 equals to 1. After rearrangement, we have P1 V1 equals to P2 V2. So in condition 1, the pressure and the volume are known, and the question is asking for the pressure in the condition 2. So a little bit of rearrangement will give me P2 equals to P1 V1 divided by V2. So P2 would be P1 1.3 atmosphere multiplied by 535 milliliter divided by 1.05 liter. So as you can see, the unit for the volume is different, and we need to have the same unit to solve the calculation. So I multiply the top unit by this unit conversion to have it in liter. Solving the math will give me 0.66 atmosphere. So this is the pressure for the condition 2. Now, what else can we do with the ideal gas law? The answer is stated in the title. We can calculate density and molar mass. Now, how? If you remember the ideal gas formula, it was PV equals to nRT. And if you remember N, the number of moles, you can calculate it by dividing the mass of a substance, grams per molar mass. So you can divide mass by molar mass, and molar mass is gram per mole, and you can calculate the number of moles. So here we can abbreviate the molar mass as mu. Therefore, if I substitute number of moles in ideal gas formula with gram per mu, I can rewrite a new formula. And if I rearrange the formula to calculate mu, which was molar mass, I can have mu equals G RT, gram RT, over PV. So you can see molar mass can be calculated by using ideal gas formula. Now, if you remember density is mass grams over volume liter. If you look at the formula to calculate molar mass, we have gram over volume. So this is the definition of density. Therefore, I can replace it with the density. So doing that, I can write mu equals dRT. I replace gram over volume with density over P. And from here, I can calculate density, which is mu P over RT. Now the application. If 11.4 grams of a gas occupies 5.52 liters at 1.10 atmosphere and 12 degrees Celsius, determine the molar mass of the gas. So to calculate molar mass, we have the formula mu equals d RT dirt over P. So if you look at the question, we have 11.4 grams and 5.52 liters. So we can calculate density, gram per liter. We have 1.10 atmosphere, so we do have the pressure, and we have 12 degrees Celsius, the temperature, but we need to convert that to the Kelvin, so we simply add it to 273. Now, density is 11.4 gram over 5.52 liter. So we have 2.07 gram per liter. Now the molar mass is the calculated density, gram per liter, the gas constant 0.08206, liter, atmosphere, moles, Kelvin, and temperature 12 degrees C, so I add 273 to that to convert it to Kelvin. Divided by 1.10 atmosphere. So atmosphere will cancel out with atmosphere, liter with liter, Kelvin with Kelvin, and what remains is gram per mole, which is the unit for molar mass. Doing the calculation, the molar mass would be 44.0 gram per mole.